Okay. So okay, I've talked about this. So you witnessed the first-hand experience of agricultural spray in drone, live demonstration on the field, and how it sprays is discharged as chemicals for crop protection. Oh, okay. So also you are going to join a team to build and fabricate a fixed wing UAV for farm aerial inspection. And lastly, so integrated aerial precision is part of our sponsors and also our supporting partner like ISPA. Hello. You know my audio is on. Nothing is wrong here. It's my mic is on. It's not muted. Okay. All right. So I'm going to be starting this again. I got a message that people can't really hear me. So apologies for that. All right. So for the PAIP practicals, I mentioned earlier that it's very, very important for you to join this practical if you are on site in Nigeria. So the virtual facilitation section is strictly for people who are not within the who are not in Nigeria presently as we speak. So they can join from different parts of the world to understand what is happening in the precision agriculture world through this virtual facilitation. But beyond this virtual facilitation, we have the on-site practicals where you're going to have hands-on experience, get the physical training where you understand how to use some of those precision agriculture tools to collect data, process them, make informed decisions that can help you spread precision agriculture. So, what are the benefits? So, the practical is going to be taking place at the Federal University of Agriculture in Abeokuta, FUNAB, starting on Tuesday, 26th of November to Thursday, 28th of November, 2024. So these are things you stand to gain. You are going to get a copy of the Drone Professional 3 book, co-authored by Mr. Femi Adekoya, the Flying Farmer, who happens to be the vision lead for Operation Field Academy. So this book is very rich and robust. It's a compendium of the current best thinking of drone experts and professionals around the world. And this actually talk beyond precision agriculture. So you're going to have different perspective or application of drones in different career space. So also you are going to be put to test before you also learn about how to use drones physically. So we're going to be placing you on a simulation platform where you get to accustom and fascinate yourself with the drone controls from the remote pad, understanding directional controls, understanding safety, awareness, and all of this information you need to learn about as regarding flying drone safely and responsibly before getting to site. So after the simulation process, then you get to go practice what you've learned on the simulation platform, demonstrate it in the live occurrence, like through an instructor-led training, where you're going to be guided through things you need to do, how to start the drone, in case of emergency, birds are flying, just need to keep yourself in check. So this is going to be done through an instructor-led training. So also you get to have a globally recognized certificate endorsed by International Society for Precision Agriculture. So ISPA, International Society for Precision Agriculture, is part of our sporting partners, and they actually endorse this program. So this is a global brand spreading precision agriculture around the world, and they so much endorse and give credit to this program. So also you're going to learn about the act of autonomous mapping, where you are going to do 2D mapping, and also aside from 2D mapping, process it into an NDVI, understand about the site information of farm terrain, the reality of what is happening on the farm. So this is going to be exposing to you in details things your naked human eye fail to understand, fail to see, fail to detect. So this data can help you to detect them, discover the reality of what is happening, and make informed decisions that can help uh, achieve efficiency in farming practices. And also, you're going to witness the first-hand experience of agricultural drone spraying, which is used for pest pest control or plant protection solutions, spraying of chemicals like pesticides, without herbicides, insecticide. You are going to see how this thing works. So beyond the normal backpack and knapsack sprayer that we've known, you're going to see how this can really help save the time, do the work efficiently, and also still prevent farmers from getting directly exposed to agrochemicals, because when you're using backpack sprayer, you get to touch this chemical so much more because it's getting closer to you. So you can do it with drone faster and also save the time. And you're also going to be joining the team to actually build a fixed wing drone, because we have various arrays of drones. If you all remember, in the last class we had with Mr. David Okpate-Ibo, he mentioned in the categories of drones, the fixed wing, the multi-rotor, the VTOL that we have, and all of that. So this fixed wing can be used for large scale mapping, like you said, and all of that. So we are going to be learning how this actually works, and it's more like a normal conventional airplane. You understand the principle of flight, how all these things work. So the physics, the aerodynamics behind this aircraft, yes, will be taught also in the physical class. And lastly, you get an internship opportunity. So we integrated aerial precision is going to be like giving out internship opportunity for the best brains we have during the course of this training. So that means it's a challenge for you to demonstrate your competence, ensure you meet up to the task, and integrated air precision will give you an internship opportunity. Yes, so you need to push your best foot forward, yeah, to be able to benefit from this. So for you to benefit from all this aforementioned program, it's required for you to also make a commitment fee of 50,000 naira to secure a spot for the on-site participation. The reality is that the commitment fee is far even beyond what the program is going to give you, the benefits and things you're going to derive from the program anyway. So just plan yourself and ensure you do the needful, or so get information. So the okay, the deadline was actually mentioned earlier before this day. Today is supposed to be the deadline for the payment, but so we are still going to give grace to like Monday. So by Monday, which is next week Monday, so we expect you to have been able to do all the needful so you can secure the program. So this will really help in the aid of planning and everything to prepare for the program. So once again, the venue is Federal University of Agriculture in Abeokuta, FUNAB, and hostel accommodations are around the university premises for non-residents. So myself and a team are also looking into how we can help you get the accommodation information so it can help you in planning to be able to stay around for 3 days to witness this practical. So this is the payment details. It's Precision Feed Academy Zenith Bank account. So I am Joseph, the program manager. So, and this is my number here. So you can always call on me if you have questions, and also you can do well to write to precisionfieldacademy@gmail.com. So we always check that from time to time to see a way to respond to you very fast. Thank you. So this was quote one, some of the snippets of quote one, the picture sections, networking, and all of that. So let me bring to the podium our speaker for today. Okay, so today's topic is Internet of Things, that's IoT, an embedded system application in precision farming. And our speaker for today is Mr. Matthews Ajibola. He is the founder and the CEO of Mountain Systems Limited. So let me quickly read through his profile as I bring him on board. So Mr. Matthew Ajibola is a multi-talented technology entrepreneur and embedded system engineer with a specialization in precision agriculture. He has a diverse background ranging from product development to founding startups. With over 10 years of experience in technologies and startup, he has expertise in application development, product design and development, PCB design, that's a printed circuit board, PCB design, ARM context development, I think that should be microcontroller. So PIC, programmable integrated circuit, PIC programming, they are also a microcontroller. So automation and robotics, big data, precision horticulture, plant breeding, agri-tech, cloud computing, business growth solution. So recently, Matthew Ajibola has focused on Internet of Things, which is IoT, with edge computing, artificial intelligence, and cybersecurity on cloud and the application of agriculture 4.0 for precision agriculture. He has been involved in developing and deploying digital agriculture technologies within and outside the International Institute for Tropical Agriculture, that's IITA in Ibadan. His work includes the development of off-grid, that is not using electricity, off-grid / IoT precision irrigation system called IWET prototype, which received grant from the IITA and the Cocoa Research Institute of Nigeria, Syrian. In 2023, the IWET prototype led Mountain Systems Limited to be selected for the Pluacom Make in Africa mentorship program. So Maltronis was chosen as one of the top 10 startups for a pool of applicants over 34 African countries. Wow. So in 2018, Matthew Ajibola joined GRIT as the Chief Technology Officer, that's the CTO, to develop a grid first prototype, which qualified the startup for the Facebook Accelerator Challenge. So throughout his career, he has developed over 5 architect solutions and has been working on projects related to smart climate, biogas technology, artificial intelligence, automation, Web 3.0, and renewable energy. So Matthew Ajibola is passionate about building agriculture 4.0 protocols and solutions, and he is driven to see ideas with established proof of concept and value proposition come to life. So he is a goal-driven individual with a focus on productivity, capacity development, and entrepreneurial spirit. So, Mr. Matthew Ajibola, you're welcome to the stage. You have the floor, sir. So, if you can hear me, Mr. Matthew Ajibola, you're welcome, sir. Hello? If you can hear me, Mr. Matthews, please, you have the stage now. Okay. Just give me some few minutes. I'm trying to get through him. Hello. Okay. I think our speaker is having issue, so he just logged out of the studio. He's trying to connect back. Just give us a few minutes to fix this. So while we go ahead. Um, Hello, Mr. Matthews. Are you back? Hello, Mr. Matthews. Okay. Hello. Okay. All right. Thank you very much.
Hello? Hello?
Hello, I can hear you. I can hear you. You're welcome. Uh, you can upload your slide, present your screen from where you are, so I can bring it to the stage.
Hello?
Hello, hello, I can hear you, I can hear you, I can hear you.
Hello?
Hello, I can hear you, I can hear you.
Hello?
Hello, I can hear you very well, I can hear you. I can hear you very well. I don't know if you can hear me. I can hear you, I can hear you, I can hear you.
Can you hear me?
Yes, 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 yes.
Hello?
Yes, you are audible. I can hear you, I can hear you, sir.
But I can't hear myself.
Ah, but I can hear you, I can hear you. Probably, can you log out and log in again? I think it's the network, but I can hear you very well, loud and clear. So if you can't hear yourself, I will just suggest you log out and log in again.
Hello?
Hello,
Hello?
hello, hello. I can hear you.
Hello?
Hello, I can hear you. I can hear you. I can hear you. Hello, hello. I can hear you very well. I can hear you very well. So you can go ahead if you can hear me. You are audible very
Hello,
well.
Mr. Martin. I can't hear you. I can hear you now. Can you hear me?
Yes, 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 yes. I can hear you.
Can you see my screen?
Yes,
Hello?
yes, yes, yes. Yes, 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 yes. I can see. I can see.
Hello? Hello, I can hear you. Can you hear me?
Yes, 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 yes. I can hear you.
Actually, I can't hear myself.
Okay. Please. You can log out and log in again. You can log out and log. You can log out and log in again, but I can hear you very well. You can log out and log in again. Yeah, I'm hearing you
Hello, I
like
can
now.
hear you. I can hear you.
Hello, I can hear you. I can hear you.
Now you can upload your slides or present yourself from You can see my slides, right? Hello?
No, 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 no. I can't see it. Oh. Okay, let me bring it now. All right. Okay, we are good. We are good. I can see it. So you can present your slideshow.
hello, I can hear you, I can hear you, I can hear you. Hello,
Hello, hello.
hello, I can hear
Your
you, I
slide
can
is
hear you.
on. Your slide is on. Hello, hello. I can hear you. I can hear you. Hello, sir. I can hear you very well. So you can go ahead.
Hello, if you can hear me, I can't really.
Yes, yes, yes. We are good. I can hear you. But if you can't hear me, I will advise you log out again. So you log. I will advise you log out and log in again. But I can hear you. Your video is on. Your slide is on. And you can also do it to check the private chat. So I'm communicating with you.
Hello,
Hello, hello, hello. We are good.
if you can hear me, I can't hear myself, but I think I can just start talking or presenting the slides because I couldn't hear what I couldn't hear. I can't hear anything. But if you can hear me, it's great to be here. Sorry for the network or sorry for the little technical challenges that we are experiencing.
Okay, we can go ahead. You can go ahead, sir. You can go ahead. Sorry, everyone. We are experiencing a technical issue here. I can hear our speaker, but he's complaining that he can't hear himself. So we are just trying to fix that. So just log out. Just give us a few minutes to fix it. Sorry. Hello.
Yes, I can hear you. Can you hear me?
Yes, yes, yes. Loud and clear. I can hear you very well.
Thank you very, very much. Sorry, everybody. Sorry for the delay. Uh, we- so we
I can hear you. You can do how to upload your slide now, so you can start. So
yeah, I
be
want.
great.
I think we have different like different is a live demo that we want to demo. We want to follow up this session with since it's purely applications of an embedded system. So there are not single slides. There are different sessions that to do live simulations with this session that we were I'm holding. So I'm trying to share the
Okay.
entire
Yes.
screen of my screen. So
Okay. 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 All right. All right.
can
No
you see my
problem. You can go
can
ahead.
everyone can everyone see my screen now? Where we're having a live simulations of different schematic layouts of a field. Good everyone. Hello, hello.
Hello. I can hear you. I can hear
Yeah,
you.
yeah. I'll
I
please,
can hear you.
if my slide changes, kindly notify me. I will just want to be certain if if the change is it. Are you seeing sections of those slides changing?
Yes.
Then
Yes. It's
please
changing. It's
can you see
changing.
this? Can you see the screen where I am? That there's a animated simulation.
What I'm seeing here is a microchip, PIC microchip.
No,
That's
no,
to be the third slide.
that what I want to confirm. I've already changed the slides, so and that's what the slide is different windows, different sections. Because you can't have a simulation from on this slide, so there's a real. Uh,
Okay.
can you see this screen? Please, can you see my current screen? Hello, Mr. Joseph. Please, can you see my current screen?
Yes. Yam and
Yeah,
cassava plot.
yeah. So we start here. What I wanted to do with these sections of the embedded systems and IoT is to make real life simulations, whereby it's more practical. It's not just presentations of the screen of the slides, but I think we have a little bit of delay with the network. But I hope the many sections that we have will be able to learn one or two things from each other. This is a cassava and yam feed where we have different irrigation design. So in these sections, we want to do applications of IoT and an embedded system as related to water and climate control. So there are two practical solutions that I structure for these sections. One is water as related to the soil conditions on the field, and second live demo that I will plan to put up through is climatic control systems that deal with the temperatures and relative humidities. So we want to use these two projects to do real-time applications of embedded systems as related to agriculture. So before we not dive into a kind of theoretical part of these sessions, because understanding, see this system working live, give meanings and enable us to be able to know the impact and the importance of embedded systems in the modern day agriculture. So when we talk about embedded systems, we're all talking about combinations of the hardware and software to come together to perform specific functions. Now, on my slide, we have a yam and cassava plot, and we are doing what is called block type irrigation systems. So the blocking type irrigation system means on your plot of a land, maybe 1 hectare, you want to irrigate a bit by bit of that land. Now, in a 1 hectare of land, maybe 120 square meters, you don't want to irrigate entire field. You want to design a plot pattern, maybe one of the plot is irrigated, the other one is not irrigated, the other one is irrigated, the next one is not irrigated. How do you come up with it? Then before you now automate it. So there is a pattern, which is one of the current projects that we're successful with, is to create this kind of irrigation systems whereby there is a precision water management and water applications into the crops at a particular time. So we have on this slide we have the blue indicated portions where water is coming into, and the white and black indicated where water will not come into. The yellow blocks there it indicated the intelligent control systems, and the upper part of the blue indicated also distribution outline in another plot of field. And this system is only 1 hectare of land, and we planted there, but we want to intelligently monitor them. And with the help of embedded system, this was able to carry it out successfully. Now, what are we doing here? We're trying to create intelligent systems that supply water using off-grid power system to specific functions. Now, irrigation has been designed, the layout has been structured out, the piping, your solenoid, your drip lines, it has been well calculated. If it's not the technical issue that we have, there's supposed to be, we want this session to be interactive, whereby any of the participants can give me amount of materials, drip lines that will be used to design irrigation in 1 hectare of land. I don't know if anyone can just give us that volume of drip holes that is needed to be able to design irrigation layout in an hectare of land. Can we just get that in 30 seconds? Maybe it's 20 meter square material that will be needed, or is 200. If I can get that, you can drop me a message. You can drop the message in the comments, like within 30 seconds, that person gets something from us. Now, each of the blocks, we put in what is called soil moisture sensor, water volume control, that taking data from the soil and taking water from the soil, and it will get the at specific times. This was able to get done because we understand the importance of modern day computational systems in agriculture, and we'll be able to calculate amount of water that is needed, and this with the help of the computational system known as embedded systems. I will share another demo before I go straight into my slides for today. This is another super point where we are applying the knowledge of an embedded system in carry out irrigation activities.
Hello.
Yeah. That's this demo also is showing another layout design of smart irrigation system that is being designed to be able to manage and control volume of water. Now let's dive into today's slide fully. I think I could be able to give us a broad view where we want to apply embedded systems in agriculture. What is embedded systems? One of the things we should look at, what is embedded system? How is it important to agriculture, and how will this be the next big thing for us to look into if we are going into agriculture? Now, agriculture these days is go beyond the old and cutlass that our forefathers are using. We are the new generation of farmers. How do we farm? We want to farm in a smarter way. Then, what are the things that is needed? Embedded systems have been successfully deployed. How can we bring that into the modern day agriculture? Is what we, the generational farmers, engineering and computer knowledge, we can implement systems that can automate, control, monitor of traditional way of farming practices with a model to by writing different computerized algorithms to perform specific functions on the field. When you look at embedded system is everywhere. With the help of embedded system, we can be able to be connected together across the world. We can be able to share information together, which is what we're doing currently. Embedded system is within us every day of our life. Now we are bringing this being applied in other fields. We have it in electronics. Now, in terms of electronic design, our modern day electronics is not that big like before, because there has been a microchip that has memory that can be programmatically instructed to perform specific tasks. This has drastically reduced the amount of components that is needed to be able to design a specific system, whether you want to write a thermometer system, want to create a measuring intelligence system, as related to when you look at the medical field, you want to have a system that can diagnose cancer, look at the human structures, everything that you can ever imagine. Now, with the use of microchips that is programmable, we can be able to achieve a micro system compared to where we have a supercomputer that is as big as maybe a whole living room, because these are distinct components used back then. Now, with the help of transition from integrated IC to programmable IC, embedded systems start playing role. Now we already have this in the medical, in automobile sector, for robotics, satellite communication, and other field of life. We look at it in agriculture. How do we apply these systems in agriculture? Number one, when you look at your drone is made up of design and developed by the embedded system engineers that bring in on board camera functions, different IC for image processing, different GPS coordinate module, and different other components. We're able to interconnect with the microprocessor to be able to design the drone that we're having today, to be able to perform a specific function that drone is doing. The drone system was able to come to reality with reality by the help of knowledge of embedded systems background. So we have it also now. Apart from in the drone sector, look at your monitoring of farm. You want to look at your animals. How are they doing? I think that there has been a section before this earlier, whereby there was a doctor, a female presenter. sharing products that are already designed for cattle and I think other animal or boundary systems. Now, this is out of embedded systems, whereby you can use it to design to monitor the conditions of your chicken, your cattle. In terms of precision farming, you want to make your tractors to work without not controlled by the human. This is done a driverless factors. This can be achieved with the knowledge and the background of embedded systems. When you look at the supply chain line, you can apply this. And in terms of aquaculture, you can also apply embedded systems in order to ease and optimize performance and get you a better result. With the help of the embedded system, these are things that the modern agriculture 4.0 is all about. And we are glad that we are taking this move to be able to bring this new protocol into agriculture. What are these architectures layout of embedded systems? We have your application, we have your middleware, we have the operating system, we have the drivers. Now, when you talk about application systems are either those applications that you have on your phone, for example, WhatsApp, and Instagram. Any of these software that you can install on a system, they are called application systems. Now, this application system has the ability to be able to send information from the interface to communicate with the microprocessor, with the microchips, because there is another layout of program which is called middleware. Middleware are firmware that interconnect your application software with the operating systems of the microchips, and that's wrong. Now, there's another program layout which is when you talk about your operating system, either in your computer, your phone, your microwave. Each of these systems has what is known as operating system. Operating system is not just for your laptop alone or for your phone. So there are different kinds of operating systems which are made specifically for particular hardware that is being designed. Your modern day TV also has its own operating system, but generally we call it firmware. Then we have application drivers. Application drivers are these drivers that allow each of the modules to be able to reach each other. If you can remember, back then when you get a printer, they will have to take the driver, you have to install it. These are another level of programming which is being structured and come together with the help of embedded systems. So in connectivities of this is what made up embedded system that we're talking about today. Embedded system softwares that we use, every walks of life has their tools. The medical, you see them whether with their stethoscope, the mechanic or the architecture, you see them with their drawing layout, use of AutoCAD and different software to design them. The mechanic, the mechanical engineer, you see them with the AutoCAD, which they can design solid works. So in the embedded system industry, what are the tools that you need? These are various tools. We use the MATLAB, we use Arduino, we use MPLAB, we use LabVIEW, we use Visual Studio, and this is being used by so-called embedded system engineers to be able to design and develop any product, we either from prototype to ready to use product, go to the market. With this, we can be able to conceptualize your idea. Embedded system hardware components. So in embedded system, it's just like you want to create human being. Now, when back we remember, we as human beings, God created us in a way that you have your head, every part of our body, and they said on a particular time, it breath of life. So in embedded system world, we are like a god that want to create something living. That's where you have your AI, your artificial intelligence system. These are where applications of embedded system is being used, whereby you can design a system that can help you on the field, maybe to carry your produce from one point to another point, depending on how the system is being, the robot is being programmed to be able to do that specific task. Now, when you are designing embedded system, there are key things, elements, there are key components that come together before you can be able to start programming microchips. So, first of all, you need to supply power into the microprocessor layout. So the power, every of these microchips has that limited power that they can take, which range between 0 to 5 volts. So before you can be able to talk to them, because their brains, they are empty brains. So embedded system chip is just like human brain. The human brain has been programmed by God and developed by the day to be able to recognize and do a particular task. So embedded system also, you can programmatically develop it to be able to perform specific functions. Now, before you can be able to talk to them using specific programming language, either your C++, your Java, your assembly language. So you need to give them what you call life. You need to give them power. You need to understand the memory. You need to understand the actual layout of the chip that you want to use, whether you want to use ArcMed to be able to develop the specific product. You want to use your PIC, that PIC 18F45, depending on the range of this family that you want to use. And you must understand the architectural layout. They have what you call bank memory. So you need to understand the register, how to talk to the register. So, but how to the registers and the memory capacity of each of these microprocessor that you are microprocessor and microcontroller that you want to use to develop these solutions for the farmers. So you need to understand them. Now, the programming language that you use, we have the C and C++, that are the model, that are the fathers of all the father when you talk about hardware development. So as you add the hardware and the software, there are different languages that you use to be able to talk to this component. So as embedded system engineer, you need to have knowledge of C and C++. Assembly is all the program, no matter what your program is written in Java or other language that you want to make it to work on the microprocessor, they are being converted back to your assembly. Because one of the things that the computer understands is 1 and 0, is number. Now, before you design any product, there is what they call whereby you design thematic. You design the layout, you can be able to simulate it. So one of the things that I wanted to do in this session is for us to be able to see a live simulation of temperature control and water, but due to this technical the technical issue that we have earlier, I don't want us to waste time. I just want to dive into this slide. So we not able to be able to run that demo. But in every single product that we are holding, including our laptop, our phone, there is always what is called thematic design. So the thematic design is whereby, as an engineer, you bring different components that you will need to bring out that idea or that invention. So understanding the registers and understanding the data sheet of that component, the manufacturer or the inventor has already written the functions of that component with the aid of the data sheet. Then, as a developer, you can now open your software, your thematic software, that you are using Pro Tools or you are using OCAD and the rest. You have numbers of them like that. Then you can be able to now start bringing them, connect them. You understand the structure, where the positive leg is, the negative leg, the pins for input and output functions. So this is an example of thematic layout. Now, with this thematic layout, you can simulate that, okay, if you simulate it, oh, it works, or then before you proceed in now designing the real life object. So with the help of thematic design, you can be able to know the output of the product that you want to design for the farmer. We still keep on put in our conversation that we are implementing or applying embedded system and IoT in agriculture. Now, when we talk about IoT is under embedded systems. So it's one of the protocols being carried out under embedded system as related to taking physical data and putting it on the cloud. What are those physical data? You are using sensors to take your environmental conditions, and then programmatically you can put those information and interpret it with the aid of computer knowledge or with the aid of computer programming language, and make it useful to the user by sending it either on the cloud, whereby you can see the live simulation. That is what IoT is all about. IoT is just about taking your environmental conditions or taking things from the physical world into the virtual world, and for us to be able to make decisions with us, to be able to know the conditions where we are applying our solution to. So we have different modules. So we have components that comes together to be able to make a specific function. And now, when we started, I said we want to do a demo where I call it inside my slide, we call it climate control systems. So an example of that demo that we want to make that product is what is showing here. So we have a DH22 sensor, which is temperature and relative humidity sensor. We also have a GSM module. Now, the key role of this module, is the data communication protocol line, and if you want to use GSM protocol to be able to send your data information across the internet. So, or you can also use other protocol to be able to send your data. You can use the Wi-Fi to be able to send data, but because of compatibilities of design, we make this system to be able to have its own GSM module to be able to communicate like your phone. This GSM module enables you to put in, and then you can use any of these networks to be able to put data into the hardware, into the micro controller, to be able to get data through its input and output pin, to be able to send it on the cloud. Either you want to communicate using HTTP protocol, or you can also use what they call MQTT when affiliated to IoT. These are the protocols that you have to come up, you have to design, work with, to be able to pass information over the cloud through the use of embedded system components. So we also have other modules that we interconnect together. A good example is we have a camera that is connected on a ship, and it's just like when we're talking about our drones, which this company is know about, to be able to create awareness, bring drone application to the farmers, which the Integrated Precision Academy and the company is all about. Now, the drone they carried along either the DJI different modules as a microcontroller system lay out on the board, and with the camera and different computerized algorithm is being developed to be able to make that camera to perform specific functions and send that function into the microcontroller. Microcontroller processes and send it back for us to be able to see, for us to be able to see, make it a meaningful data for us to be able to interpret as human. So these are modules. We also have a ZB module. ZB module is a wireless communication module. That is, if you want to send data from one point to another, instead of using your cable line, you can now use a ZigBee module to be able to do wireless communications. Now, when we talk about module in embedded system engineering, it's just like when we are talking about a woman that wants to cook soup. Now, before you can cook a pot of soup, there are different ingredients. There are different ingredients that you use. You talk about whether you want to cook a stew for rice, you buy your pepper, your tomato, your onions. Now, you grind them. It's combination of these that make up a soup. Now, this is that make up a soup. And now, the same thing is what happens in embedded system community, in embedded system world. Components come together to be able to make a specific function, a specific product. Every technological solution that we are seeing today, there are components coming together to be able to perform specific tasks. A good example, another example that we made about when you talk about component modules for us is when you look at your phone. We have your screen, we have your screen, we have your keypad. Back then, that phone always have keypad. Everything is now sub-based. You have your charging port, you have your earpiece port. These are modules coming on the board. The heartbeat of that system is the microcontrollers that is on it. So each of these microcontrollers have different registers that admit functions. Take function from the module, from either wireless module, from cameras, to be able to perform in a specific need. Now, applications of these embedded systems, which are more concerned, all we'll be talking about is the theory, but embedded system is fun when we see them in actions. So this back then, about 10 years ago, where when I started my journey in moving from general engineering, now focusing into agriculture, because I want to see myself as a new generation of farmers. So this is a farm factory, and a farm factory is like a greenhouse, but now a smarter greenhouse. Now I use combinations of Raspberry Pi and other different high-level computerized systems, and we develop a Python programming protocol to be able to monitor the growth of tomatoes and give it all artificial conditions that can make that tomato grow and have a better yield. The other side of this slide that we're seeing, where the cassava is, where I developed a mixed system whereby I want to control the relative humidity of that environment to be suitable for cassava to bring out flower at a particular time. So we're cooling the environment down with the help of microcontroller system by developing algorithm that relates to temperature and relative humidity. Then the system can be able to perform that. We have another application of it. This is a point where we are having a solution deployed on the field. This application of embedded system in this slide is related to water management, smart irrigation, and we'll be able to design a system that can intelligently monitor, control, and analyze the volume of water use and send it into the cloud for us to be able to see, for us to be able to make decisions and also carry out automation systems. We have this is another application of embedded systems. We have a robotic system that is intelligently monitor what is happening down the root zone of a cassava. With this system, a farmer can be able to make a decision to know whether he or she needs to harvest his produce or know whether his produce is cassava, any root or tuber crops is ready for harvesting. And this is another application of this system. We also have temperature relative humidity system to be able to monitor conditions of a yam field and also citrus plant, whereby we are taking data and we can be able to know the climatic conditions in that area at a specific time and relate it to that conditions of the plant, then you can be able to make decisions that these were the condition, the climatic conditions of this plant at a particular point, 2 p.m., 1 a.m., and you look at the conditions of this plant, then use it to judge the data that this system is putting into the cloud. Now we also have a dash, a soft screen of real-time simulations of information that the hardware is pulling into the cloud. So, embedded system always comprises of both the hardware and software. They interconnected to be able for us to be able to see and to perform a specific task. Another way we apply embedded system technology in as related to agriculture is like a greenhouse, or inside the control system, a house. We want to monitor and set a controllable environment for specific crops to be able to grow without not using the natural lighting, the sunrise, or without not using open field. And the purpose of this is to be able to optimize the growth of these systems, and to be able to see how important a computerized system can be in day-to-day activities of the farmer as related to farming in a controlled environment, either in the greenhouse or within the house. And the whole objective of implementing embedded system design in agriculture is to be able to make availability of all year-round productions of food to be more easier and more accessible, because we know that there is more that a computerized system can do better than what human beings can perform. Now, that is where we are applying IoT. One of the beautiful where also we apply IoT so far is as related to the biogas. So we will be able to create something sensible with the help and knowledge of embedded system design, and to be able to monitor amount of biogas that is coming out from the dish, and then see is it suitable for cooking or for use. Then we can be able to make decisions with it. And these are the beautiful and how we can apply embedded system in agriculture, for modern day farming. And thank you very much. This is all of our slides, and we are open. I'm open for you to ask questions. Then before we talk about real-time simulations of irrigation systems, and then we can go home and see that we are, for the new generation of farmers, embedded system will play a role for them to be able to farm. And agriculture now is not more the way it used to be. That with the help of computerized systems, that we are not making use of our own, then we can create a smart system to cut or to make a ridge for us. Now we want to apply habitat chemical. You don't do that with your knapsack anymore. With the powers of drones, we can be able to do that. And what makes drones to be possible? Because we have knowledge of embedded system design. So the new generation of farmers are the people that will implement technological need solutions into agriculture, and in order to make food available for all. Thank you very much.
Right. Thank you so much, Mr. Matthew, for sharing your experience, your ideas, and your past projects with us. Hello, I believe I'm audible, right?
Yeah, I can hear you.
Okay, sir. All right. So thank you for sharing your experience, your expertise, and your past project. These are real life projects you've worked on, and to gather field reports, data, and all of these things to actually help to coordinate farming in a very more productive and measurable way, because they say anything you can't quantify, you can't measure, you can't manage it. So, but I mean, using systems like this can actually give you a precision-based approach, guide your approach, yes, and help you know the best kind of decision to make at a particular time. I must say, what you're doing is really profound, and yeah, it's really good that you are here in Nigeria and you are doing this. And we believe that you've inspired our participants. So we also see that we are going to be, I mean, we are expecting that we have more young people doing what you are doing too. So, like, you've been in the industry, and we are also looking into having more young people to do what you are doing, because this is not going to be a one-man fight. So it's something that we all need to democratize this technology and decentralize it for everyone to be able to, for effectiveness on the long run as a result. So currently we want to entertain question and answer. So in case we have any question from our participants, let me quickly check. So all right, I think people are. Hello, everyone. I think I lost Mr. Matthews again on this call, so let me try and get him back on stage. So we are now in the question and answer section. So if you have your questions, you can do well to drop it. People are actually giving their entries or appreciation. Okay, thank you, thank you. Joshua Bamdeli also said, thank you, sir. Um, all right, all right. Okay, so if you have question and answer, please do well to drop it. In the meantime, while we are here. All right. So thank you so much for sharing. Personally, I've learned so many things about your section today. Talking about when you have the problem you want to solve, then you tend to look into how you can go about it. Then identify what are the components that I actually need, the sensors, the microcontroller, the kind of power system you want for it. It's going to be something in solar-based renewable energy that can actually help it to work independently. From yeah, these are part of things I've gathered, information I've gathered during the course of your talking. Although we had network issues, network challenges, but that doesn't still stop us from learning. So I must say it's a profound one. So then also looking into, after you've been able to gather the hardware parts or put your thoughts around the hardware you want to use, the platforms, then the best programming platform that can actually help you to gather what you want to do, then give your instruction in terms of programming, coding, or line of text, so that you can share your, like, what do you really want to achieve. Yeah, put it in programming form, then you have the product then for your data collection for commercial use. Yeah, this is something very, very important. I believe when people have intelligent systems like this on their farm, it's really going to help them to be able to understand what's happening per time in terms of data, environmental data. We want to take climate information. Uh, we want to take climate information about the weather pattern, environmental, and all of these things. Because when you have all of these things as the data, these are things that is really going to positively inform your decision as a farmer to be able to streamline your kind of farming practices in a very better way. So We have a question for Mr. Matthew. All right, Mr. Matthew, welcome back, sir. We have a question for you. Joshua Bamidele is asking, as a newbie, how can we actually navigate through the whole process of embedded system? Okay, we all have anything to share from there.
Yeah, yes. The, for, can you hear me?
Yes, I can hear you, sir.
Yeah, yeah. For a newbie in microcontroller now, navigating your way into microcontroller is very, very simple now. There are a lot of kits, a developmental programming board that has been made. A good example is when you look at your Arduino, you look at your Raspberry Pi, you look like your Node 32. They are all available to be able for you to ease in your journey. Not like before that we started that you have to take your PIC, you have to build them from ground up. So now for a newbie to dive into this embedded system, all you just need to do is get your programmable board like your Arduino to start. Before you start saying you want to start programming the chip directly, like you want to start writing the bootloader, all those. But now with those kits, with those educational kits, it's more easier for you to be able to start your journey into embedded system world. Now, when you are done there using this kit, then you can now advance to whether ARM processor, because that time you have the strength to be able to debug your code, to debug the hardware and the software if you're having challenges. Because one of the things that as the word hardware development, I will not is a challenging word, but no any field that anyone cannot overcome. So with the use of this new board, it's more easier to dive into embedded systems and you are easy to go. Yeah, can you hear me? But I mean, I can't hear you anymore. But
Hello,
I could see
hello.
the question. Yeah, yeah.
Yes.
Yeah, what are the different sensors for soil, moisture, temperature? Now, I think the question is, what are the different sensors for soil,
Are there
moisture?
different sensors? Like, are there different sensors that I can
Yeah, yeah,
use
yeah.
for?
Yeah, there is. For example, when you are talking about soil moisture, there are two ratios you you do mapping for soil moisture. So we have what we call capacitance sensors, and we have what we call resistance sensors. So there are soil moisture sensors that work with the principle of capacitance. So from the word capacitors. So what really happens is that before when you dip them into the soil, they don't just pick data and send. They absorb the data. They absorb it in and take proper accuracy before sending it out. So it's just like when you talk about your capacitor in your electronics, your capacitor is not only just filtering signals. No, it's also absorb it before taking it out. Then it absorb it, filter it, and give you the clean information, the clean current. So that's the principle whereby soil capacitance sensors work very well. But when you are using resistance resistance based soil moisture sensor, it doesn't give you accuracy. So not even when you want to perform high level precision. So I will encourage anyone that if you want to use soil moisture sensor to be able to develop products, is more better to route to capacitance based soil moisture sensor. Now when you talk about the temperature sensor, there are different kind of temperature sensor. The temperature sensor, do you know that soil temperature sensor is different from environmental temperature sensors? So that depending on what you want to do, that will not determine the kind of temperature sensor you want to use. And also, manufacturer also very, very important when it comes to picking up all these modules to be able to develop products. the manufacturer experience or quality of giving you good component module to be able to develop your product is very, very important. So these are things to look for whenever you are making order for any of these sensors. And you must learn to read their data sheet. Data sheet reading is very, very important because you can't play with my product if you don't understand the way I've architecturally route them out. Just like you purchasing a new product, the manual, you have to go through the manual. So any module that you want to develop, you must take time to study the data sheet. Because understanding the data sheet is what makes you to be able to do dynamics with those components. It's what makes you to be also, you can also reach out to the manufacturer that this and what that you've noticed about this component, and you can make adjustments also. So reading the data sheet is one of the things that you as a developer you need to understand. In one of the things in embedded system world is that understanding data sheet is one key point that you need to put into use.
Okay. Thank you very much, sir. So another question here is, so any suggestion about platforms where to go to learn independently on how to do programming? Okay.
Yeah, yeah. There are series of see. Internet is now our best teacher. You could learn a lot of things within this space. So, but one of the things that if you have a good platform like the Precision Field Academy, it's easy your journey because you can access expertise that will shorten your self development. When it comes to self development, little I may be right or I may be wrong. When you come to self development, it takes time to be able to master a particular art. But when you have access to expertise that can shorten your journey, I will advise that you can get into academy like that because they have access to good resources and direct you to what you need straight up. Also, it has open you to make different search. But if you have access to mentor, I will advise you also route to that mentor. So the internet is a good space for you to learn, like depending on the programming knowledge that you want, programming skill you want to learn. But I always recommend as 3 school 3, W3 school 3 is very, very good. They simplified their tutorial. Any of the programming language that you want to learn, that platform is very, very good, and they summarize things for learners to be able to learn as quick as possible with real life practical on the cloud. Thank you very much.
Okay. Another question here is asking, do you offer training programs in mechatronics?
Yes, you can come. Like if you want to do any training, Field Academy is Precision Field Academy can route you. So there's already a joint work. So if you want to get access to Precision Field Academy, then you can also have access to those materials and expertise in maltronics. So that's one of the things that the Precision Academy has already created. So it has created a platform for you to reach expertise like us and companies also. So once you have a good relationship with them, make your needs known to them, then they can key you into opportunity that they have at hand, which is like opportunity like Maltronics and the other company that they already have partnership with for you to grow.
Okay, thank you, sir. So Joshua really asked that starting from the type of application we will be needing to do the appropriate types of tools needed into the applying it to solve the precise problem. I don't think I get that question.
Okay, maybe what type of application is needed to approach, or maybe
Yes,
I think let's structure it this way. I think is the type of application needed to be able to approach a particular problem, to be able to solve it as related to agriculture embedded system. right?
Yes, 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 yeah. I think
Maybe
yes.
we speak. So when you are looking at the right applications that is needed to be able to tackle a specific problem, a good example, let's use drone as an example. Now, there has been a drastic advancement in drones. Now, there is recently that I and founders of Precision Academy were talking about using drone to carry out irrigation activities. How possible is that going to be, and how affordable is that going to be? Now, this is a problem that every farmer is experiencing. They want to irrigate their field as quick as possible, and they don't want to go the route of setting out the complete system. Now, how do drone do this? Now, we all know the capacity of drone, that can drone carry 200 liters, maybe 200 to 500 liters of water, 5,000 liters of water, or 2,000 liters of water. Drone cannot carry 2,000 liters of water, 5,000 liters of water, because now for you to irrigate 1 hectare of farmland during dry season, you will not be talking less than 5,000 liters of water. And at each plant, let's talk about your plant. Each of the plant will take nothing less than maybe 50, maybe 50 to 20 liters of water. Now, this is a problem. So we need to start now approaching it. I remember we were talking about when I was talking about with some of my founders, we are talking about whereby we put in hose on the drones, then we have a rollers on the floor. When the drone moves, the system moves also. Then the system is taking water from the ground. The drone is just taking the hose and moving with it. So there is a lot of things routing around that system. So now we now start looking at what are the keys for us to be able to solve this problem. So the knowledge of mechanical will come into place, the knowledge of plumbing, water management will come into place, the knowledge of electronics will come into place. So these are this different area that will come together to be able to what to be able to solve that problem as related to using drone to carry out irrigation operations on the field. So you need to identify the problem first. Then once you understand the problem, your knowledge in embedded system will now help you to route it, that this is what you need. It's just like a medical doctor. Medical doctor, we have different field or different expertise in the medical line. Now, if somebody is the doctor that attends to pregnant woman is different from the one that attends to somebody that have a knee injury or somebody that have a spinal cord injury. So now they will identify your problem and skill you to the needed expertise. Now, the tools that they use to carry out operations, surgical operation for a pregnant woman that they want to operate is different from the one that is someone that have an accident. So the problem will determine the kind of tools that you use. But in summary, there's always a general tools for you to kickstart. Thank you very
Yes.
much.
Okay. Thank you so much for answering that question. So we have two more questions. So let's quickly talk about them before we call it a day. So he is asking, okay, so thank you so much, sir. I would like to ask, what is the programming language that is most needed for those interested in embedded systems in agriculture?
The first thing is for you to understand your C plus plus. Now the C plus plus now make you to be a core firmware developer. But it go embedded system go beyond just the C, because embedded system is interconnectivities of your application software. For example, now I'm an embedded system engineer, but I developed embedded system. What embedded system made anyone that pick it as a skill or as a field is that it make you have abundance of knowledge. So your knowledge base has no limit. You are not saying, oh, you are web designer, it's web that you know how to do. As an embedded system developer, you have power over both the application software, firmware, software development. But now that not limit to you as an individual. How hungry are you for knowledge will determine how good, how advanced you be in embedded system world. Because when you are developing embedded system, you may be playing with Android application, that you need to develop your interface. You don't want to use keypad on your hardware. You want them to be padless, keyless system. So that means that you are going to have write an application-based software that will maybe on your mobile phone you can be able to press button that will pair with your hardware. So knowledge of programming knowledge in embedded system world, they are in series and sequence as we are going in the field. But if we make to dive into is C++ or C. So understanding the C++ and C is very, very good for you to be able to go because that is the modern day language to be able to talk to these microchips. Thank you very much.
Okay, thank you, sir. So the last question here is from David Sonon. He said, could you tell us the name of reliable manufacturers and suppliers of soil moisture sensors? Okay, probably this one you can recommend.
Now, there are different manufacturers that are general in their Chinese products that is available that people use. But currently now I'm using a product called ESD from a German company. So they use, but in terms of cost, I would say that if you are on low budget, I will ask you to just buy from the China's open market where you can place order for a general soil moisture capacitance sensor or sensor in the open market, depending on the prototype. If you are building a prototype, use the general ones, but don't go for the expensive manufacturer. A good example, you have Passport. Passport is an American-based company that creates they develop different modules. They develop different hardware components for people to use. Yeah. Now, when you're talking about your processor, your microchips. So currently now I'm using ARM processor made from ARM microsystems. So they're one of the top notch. And then currently also I'm using Qualcomm board because these are people that are in that game because uh, your Samsung phones and your Apple phones, these are the manufacturers of those microprocessors. So and they're very, very good. Thank you.
Right. Thank you so much, Mr. Matthew. So finally come to the end of the question and answer section. We want to express our unreserved appreciation and gratitude for you honoring our invitation to also share in this second cohort your perspective, your current best thinking and expertise on embedded systems and IoT application and precision farming. Sincerely, this is a robust, top-notch, and profound class. Thank you so much for coming. And to everyone, we finally come to the end of this training, and we also finally come to the end of the third week out of the 6 weeks. So we still have 3 more weeks to go. So next week is going to be the fourth week of Operation Agriculture Incubation Program. So we are gradually moving uh, towards the end. So thank you so much, Mr. Matthew, for coming. Thanks everyone for joining.
You're welcome.
So yes, sir. Yes, sir. So we are going to drop information on the group, yes, for participants to about the updates going forward. Thank you, sir. Bye for now.
Thank you. Bye.